Lesson 5, Numbers Raised to the Zero Power. We have shown you that any numbers x, y, and any positive integers m and n, the following holds. So m times x to the m times x to the n equals x times to the m plus n. Oops, I got a pen. Sorry. Where's my pencil? There it is. All right. X to the m raised to the n would be x to the m n. Xy to the n would be x to the n, y to the n. And then x to the m divided by x to the n would be x to the m minus n. So what do you think would be the answer to 3 to the 0 power? Well, that answer would be 1. So our discovery activity would be complete the following charts using a calculator. To enter the power, enter the base, hit the arrow key, and enter the exponent and hit enter. So 2 squared, the value would be 4. To write it as a fraction would be 4 over 1. 2 to the first power would be 2, and then 2 over 1. And 2 to the 0 power would be 1, or 1 over 1. Here, our power would be negative 3 to the third power would be negative 27, or negative 27 over 1. Here, negative 3 squared would be 9, or 9 over 1. Here would be negative 3, or negative 3 over 1. And here our answer again would be 1, or 1 over 1. What do you notice about the 0 exponents? They equal 1. Okay, next. So now, any number or variable with the 0 power is a value equal to 1. So, for example, x over 3 divided by x over 3 would be x to the 3 minus 3, or x to the 0 power, which would equal 1. But using the exponents rule, we know that x to the third power divided by x to the third power is x to the 3 minus 3, which therefore is x to the 0 power, which is 1. Writing the expanded form of 8,374 using exponential notation, we can write it in this way. We have x, or 8,374, which would equal 8 times 10 to the third power plus 3 times 10 to the second power plus 7 times 10 plus 4 times 10 to the 0 power. So to write another number in expanded form, here we have 6,985,062 would be the following. Would equal 6 times 10 to the 6th power plus 9 times 10 to the 5th power plus 8 times 10 to the 4th, plus 5 times 10 to the 3rd power, plus 0 times 10 to the 2nd power, plus 6 times 10 to the 1st power, or just 10, and then plus 2 times 10 to the 0 power. So in exercise 2, we're going to simplify each expression using the rules of exponents. So in this case, q to the 0 power would equal 1. Negative 6 to the 0 power, again, would equal 1. Here we have xy to the 0 power, which would equal x to the 0 power, y to the 0 power, which would equal 1 times 1, which would equal 1. Next, we have 5 to the 8th power divided by 4 times 5. 5 to the 4th power times 5, so 4 plus 1. So 5 to the 8th divided by 5 to the 5th, which would equal 5 to the 8 minus 5, which would equal 5 to the 3rd. Here we have 8 to the 3rd times 8 to the 0 times 8 to the 4th, so we can add these. So 3 plus 0 is 3, plus 4 is 8 to the 7th. Here we can add these two, so 8 plus 2 is 10, so 10 to the 10th, over 10 to the 5 times 2, so 10 to the 5 times 2. So that would be 10 to the 10 over 10, which would equal 10 to the 10 minus 10, which would equal 10 to the 0. Take out these equals here, which would equal 1. Down below here, we have a to the 4th, b to the 2nd power. So we have 4 to the 4 times 2. Sorry, that's an a, not a 4. Sorry, guys. And we have b to the 1 times 2. So we have a to the 8th, b squared. Here we have 9 to the 5th, 2 to the 0 power. So here I am going to change this to 3 squared to the 5th times 1, or 3 squared. I'm going to go times 1 over 3 to the 8th. So now I have times 5, which is 10, over 3 to the 8th, which is 3 to the 10th, over 3 to the 8th. So now I have 3 to the 10 minus 8, which equals 3 squared. Here I have 3 to the 0, which is 1, times 5 to the 2 plus 3. So here I've got 5 to the 5th power. I believe that's going to end our lesson, and it does.